The intermediate value theorem in basic terms says if a graph of a function goes from below to above a specific y value and it's continuous, then this graph has got to cross somewhere in between. So basically, if I'm going from what they will call from, let's say, from A to B, then there's some point C where it had to cross because it was continuous. Like to get from one side to the other, if it's continuous, if there's no break, then it has to cross this overall. The most common one you're going to hear of is when it crosses a zero. So when they say below to above, you're looking for like a negative positive, but it's not always zero. It's in general from below to above a specific y value is what they're looking at overall. So for example, if they said something like, use the intermediate value theorem to show that we have a zero on, let's say, the graph. Let's go for f of x equals x squared minus 3 on the interval. So let's see, the interval is going to be 0 to 5, okay? Well, then all you essentially do is go, okay, well, first of all, we can see this is continuous everywhere. So it's continuous for all real numbers, negative to infinity, it's just a polynomial. Polynomial here, specifically a quadratic, is going to be continuous everywhere. And if I say f is 0, plug in, I get negative 3, and f of 5, plug in 25 minus 3 is 22. Well, it went from a negative to a positive, which means somewhere in between going from a negative value to a positive value, it had to cross the 0, it had to cross the root, it had to cross the x-axis. That is what you are showing. However, be very careful. I cannot warn you enough, okay? That if they would have said the same thing, use the intermediate value theorem to show f of x crosses, let's say, y equals negative 5 of the same function over the same interval, okay? So let's say at the same function, so we say, f of x is equal to x squared minus 3, and the interval is 0 to 5. Well, it is continuous, but it doesn't matter that it went negative positive. Negative 3 to 22 never crossed negative 5 down here. So you would say that it does not work in this case. The IVT does not apply here because we can't show that it had a real 0 from 0 to, or we didn't cross y equals negative 5 on the interval from 0 to 5. See, almost I messed it up because I said 0 at one point, just so you know how ingrained it is when you do these problems, okay? It's ingrained in me as well. So this is the one that I worry about that does show up every few semesters and throws everybody off because we're so infused with finding, oh, it went from a negative to a positive, so I had to cross 0. And this is true. This one for crossing y equals negative 5 would be false. And one more instance that you have to be careful about is it has to be a continuous interval. So if I gave you, again, use the intermediate value theorem to show, if applicable or if possible, I should add that in, okay, the following function. So let's say, once again, from 0 to 5, f of x equals, let's do 1 over x minus 3 on the interval 0 to 5. And you go, well, f of 0 gives you 1 over negative 3, and that's a negative. And f of 5 gives you 1 over 2, which is positive. And no, because this graph does not cross or is discontinuous at x equals 3. And that's inside of 0 to 5. So whatever this graph looks like at 1, 2, 3, we have a vertical asymptote. So even though it went from a negative to a positive, it is not guaranteed to cross in that case. So those are the 3, in summary, that you need to be worried about, and in general when you're practicing the intermediate value theorem. It is so easy, but at the same time, it can be so picky. Take your time.